that two things are going to happen at the exact same time, but my suspicion is that those are both going to cause events that will be responded to at theoretically the exact same time. Of course, the processor may pick one or the other, but they will have the same timestamp because they happened at the exact same time. They will both definitely get passed through, but classic race condition. And I believe the scheduler is something that you can either just take the default scheduler, or you can kind of tap into the scheduler and implement or override. And so you could create some behavior that resolved certain differences if you wanted to.
Yeah, back on the previous slide. So stream 1 ended. So because you merged from that, that's when stream 3 also ends?
Yep.
So if you flipped it around, then stream 3 would keep going?
No. If either of them ends,
either.
Yep.
Okay.
And that's just a nature of the merge operator.
All right. Okay.
If either ends, then it ends. Yep. The debounce operator we looked at, hopefully you all understand that. It's a good way of getting jitter out of the system, and you obviously have to accept a little delay. Here's a buffer operator. This one's one of my favorites. This was a really elegant way to analyze things in a stream relative to the things next to them. So where I saw this one implemented, and it made total sense, was in a stock ticker. I want a stock ticker where it's telling me the price every so often, every second. There's the price, there's the price, there's the price. And I want it to be green if it's up by at least 1%. Okay, I want it to turn green. But if it's holding steady, I want it to be yellow. And if it's down by at least 1%, I want it to be red. Well, how do I determine that the price that just landed, like maybe this one, is 1% more than this one, other than to have in memory this one and compare it? So this is where you write that loop that says save everyone, and then every time you go through the loop, if I have one, compare it, and then when you're done comparing it, overwrite it. You're managing your own state. Here, more elegantly, you simply say, here's my stream, I want to buffer it by 2, and then it gives you, instead of individual items, it gives you little arrays, or enumerables, or whatever, of 2 of your items. And so now you can just say, compare the second one with the first one. Now, obviously, whenever blue happens, we don't get anything, because we don't have anything to compare it with yet. So it's not until green lands that we actually get a result on this stream, because this stream is dependent on 2 things. And so you don't get the first one. But all the way up to the last one, you then get pairs. Clear? Now, sometimes what you want is this array of the results. But other times what you want is you want baby observables. You want child observables that you can subscribe to. And the window operator is what that's for. Notice some of the commonality. Has anybody here used Stream Analytics in Azure? Notice the commonality between some of these words. I didn't get any yays or hands, so maybe you don't notice the commonalities. But Stream Analytics uses some of these concepts. It's windowing and buffering and stuff. And so I would love to see an implementation of Stream Analytics using Reactive Extensions. In fact, I've been meaning to play with that. But this is kind of neat because every time one lands, you get a baby observable here. And then when the second one lands, you get another one that's also on this observable, but now you're done with this observable. This observable started, emitted 2 things, and then it ended. It had a termination. And then the next one emits 2 things, and then it has a termination. Okay? So it's not immediately evident. I don't have a good example to describe when that would be useful, but sometimes that one is more useful than the buffer. Now some examples will drive it home, and then we'll be done. This is from V4 of Reactive Extensions. I'm going to give you this slide at the end that shows you that there's like V4 and V5. V4 is kind of everything that Microsoft birthed, and then the open source community evolved, and then it got really far, and then it started getting picked up and getting popular. And then the community took it over, and they kind of rewrote it. And not rewrote it, but it was a pretty good rewrite, and it's V5. V5 is not an entire set of V4. It's kind of a subset of V4, but it's much more performant and has some other big advantages. So if you go to Netflix, that's what they're using. If you look at the Angular 2+ framework, it uses reactive extensions. It's using v5. So that's that. But there's a lot of good examples in v4 that helps you to learn some of these concepts. So that's what I'm going to show you, a few of these. So there's the URL from where I got that. Remember, you have the link to the slide, so it's easy to get that. And what I did was I just pulled all those down to my computer, and I put those in a folder called v4, so I know right where they are. And then inside there is these examples. And I'll make that large. And so, oh, man, I'm not seeing my screen. So inside there are these examples, and that's all of them. There's a lot. And the easiest way to run these, I'm just going to step up a directory into the v4 folder, and I'm going to say, actually I've already done it in my other window here. I'm going to do it again for your benefit. So I'm going to cancel this, and I'm inside the v4 folder, and I'm going to say light server. Now if you haven't used light server, that's just an npm module. So to install it, it's npm install light server globally. And then you have it. And you get to use it at the command line. And if you say light server, what that does is it serves this folder as a node folder using browser sync. And so now it's running this on port 3000. So a really good way to just say, I have a little web project and I just want to serve that real quick. So I can serve that real quick, no problem. By the way, has anybody here used ngrok? Raise your hand if you've used ngrok. Okay, I've got to blow your minds. ngrok is a tunneling program, and there's another version there's ngrok, and I could use that, but it's for pay now. You have to pay for that one. There's an npm module, so I'm here at the bottom of the screen in case you lost me. npm install, it's called local tunnel. Install that globally, and then you can do something like this. See port 3000 there? Let's jump out to my browser and go to port 3000. Oops. There we go. So there's one example. I'm on port 3000 under examples, letter count, letter count. That works on my machine. Now, how about if you guys go to localhost :3000? Won't work so well, will it? That's my machine. But let's say I'm at a hackathon, or you and I are working together on a project, and I go, well, I just want to show you my machine. So I just need to basically give you my port 3000. I need to tunnel port 3000 to the web. So I'm going to go out here, I'm on the bottom, and I'm going to say local tunnel port 3000, and I want a subdomain of foo, whatever. And it says, very well, your wish is my command. Now, if you guys go to foo.localtunnel.me, you will see my exact same thing. Is that cool or what? So now when you're working with somebody and you're working on the API and they're working on the mobile app, you go, okay, well the API is up, and here's the URL. And whenever you change anything at all, they always have the latest version because they're looking right at your machine. Super,
Is that a reverse proxy or what?
I don't know if it's a reverse proxy or not, because I don't understand reverse proxies well enough. I don't think it is.
Is it a relay or this thing? It's a relay. It's a relay.
It's a relay? Okay, so yeah. It's a relay. Okay, so I've got mine serving, and so now I can go to my web page, and I can go to all of these examples. And the first one is letter count. So here's the result of it. This one allows me to type letters in here, and it says how many letters are in there. And everybody goes, whoa, great. I could have made that in 5 minutes. I know, but not with Reactive Extensions, perhaps. What this is doing is it's reactively, so remember, reactively is like a whole new paradigm in programming. It's making things kind of happen because of their described reactive state, as opposed to imperatively walking through and saying, when this happens, then do this. To do this imperatively, you would have said, when I type a letter, then go add up the number of letters and put them in here. For such a simple example, the reactive extensions way is not a whole lot simpler, but let's go look at what's going on. Now notice that, excuse me, Edge is telling me that fired was console log 5 times. And so now if I type another letter in here, it's now been logged 6 times, right? Well, there's an interesting behavior here. If I hit A, now it's been 7. Now if I copy A, and then with A selected I hit paste, it didn't fire at all. Okay, because I didn't change anything. It went from A to A. So nothing changed, nothing fired. How did that work? Well, let's go look at this one. So I'm going to go to letter count. This is VS Code. Didn't look like VS Code, did it? Now it does. Okay, so this is VS Code, and this is the complete solution for letter count. So, we have a couple of DOM objects, no big deal there. We're just using query selector to get them. We have a thing called source, and this is going to be an observable. I know because we're using observable from event. So from event, I want to take this thing, and every time it has a key up event, I want that to result in a kick to this stream. And when you do a from event, what you get is the event arguments itself. Okay, so I'm able to enumerate into those. So at this point, after from event, I have an observable. I take that observable and I use a dot map. Think dot select, same thing. I use a dot map on it, and the function that I use to transform it is to go get the length of the target of the thing that I typed into, go get the length of it, and return that. Now, distinct until changed. So if it had 6 things in it, and it just changed to 6, don't kick. That wasn't a change in the length. May have been a change in the contents of the box. Watch this. I have an A in there. I'm going to highlight it and hit E, and let's see if fired, is that going to roll to 8? No. Because even though the contents of the box changed, the overall length didn't change, and so my event never even fired. I'm not interested in times where the length has changed. Okay, so this entire part here does nothing except for wire up an event. Okay? It's just describing how this observable is going to behave. Whenever there's a kick, I run this function, and I now have an observable, and this is the description of it. But I am not doing anything with it yet. In order to do something with it, I have to subscribe to it. So I subscribe to it, and I say whenever it fires, I want to set the inner HTML of the result to V. Remember, V is this entire value here because I've mapped my result. Remember, my result was complicated. It was an event arguments with all kinds of, event arguments are huge, right? I mapped it, and I made it something simple. Yes?
One of the things I'm getting from reactive programming compared to encouraging should have a lighter footprint and get more done with that.
I think so, yes. And once again, in a lot of these simplistic examples, it doesn't appear that way. But we'll show some slightly more complicated examples. You're seeing it already? Wait till I show you the Wikipedia search example here in a little bit, because it's similar to this one, but you'll see the advantages.
It reminds me of what happens in Scala.
Oh, yeah?
You get a lot done with a small amount of code.
That's cool. That's really cool. So here's where I subscribe to it, and I say, this is what I want to happen whenever there's, I like to call it a kick, whenever there's a kick. Whenever there's a kick, I want to, first of all, say, just on the console log, that it's been fired. I added that just so we could see that it's actually happening. But I want to put that result into that inner HTML. So, is that one completely clear? Any other questions on that one? Yeah?
What's the definition of changed? Because you're changing the character, but not the string length.
Yeah, well, in this case, we're saying distinct until changed, which looks at the current value, the payload of that observable, and says if I put those on either side of an equal operator, would it result in true or false? And so one of them results to length, :space 6. And then I change the A to an E, and it resolves to length, :space 6. And those are exactly equal to one another, and so that says false, and so there's nothing, it returns. Okay, the next one I want to show you is time flies, mostly just because it's kind of cool looking. So this is time flies, and I get this. Are we back at 1999 or what? Is this like every single web? Thank you for visiting my web page. So that one's that, and let me show that real quick. So here's time flies. I haven't actually analyzed this one. It is using a function called flatMap, which is, how familiar are you guys with link expressions? Most of you sound like you select. How about select many? So select many, flatMap, same type of thing. And which makes sense to me because it's like I want to flatten this out. The way I like to think of it is I've got an enumerable of grandparents, right? And so I've got like 4 grandparents. Well, how many grandkids would they have? I don't know, maybe 20? But if I just enumerate, I get 1, 2, 3, 4 grandparents. But if I select many into there, I get how many parents? Maybe 8? So it's 1, 2, 3, 4, 5, 6, 7, 8. So if I select many into the grandparents' children, I actually get an enumerable of 8 parents. And then if I select many a second time, I can select all the way into the grandchildren, and now I've flattened it out, and I now have an enumerable of 20 grandchildren. And likewise with these streams, sometimes it's the actual payload that you're interested in, but sometimes it's something in the payload, an observable inside the payload that you're interested in, and that's when you flat map. Nice thing is if you're using C#, it's select or select many, and it's the same concept that you're used to. So here once again we're looking into the DOM. We're doing a delay, which is another thing that you can do on a, I think that's on the observable. And then a map. And then I'm subscribing to it. I'm going to pass this one because there's another one that shows basically the same thing. Let's look at Canvas Paint. So this one's kind of nifty. I've got all these colors down here, and I can click on those. And then I can grab on here and I can paint. And this is just done on Canvas, and it wouldn't probably be that hard to implement this, but this is one where you would end up with some kind of micro state management that is just a little bit of a headache. And so this is one that does show it off quite nicely. So if you look into Canvas Paint, you can see that what we're handling here is mouse movements. And it's really interesting the way this works. We're using a subset of reactive extensions called the DOM. You can either include all of reactive extensions if you're not concerned about the size, or you can get subsets of it. And in this case, we're getting the DOM subset, which includes the ability to grab these events. So I'm grabbing all of the mouse moves, the mouse downs, and the mouse ups. And now these are 3 different streams that I have, but speaking to the composability of reactive extensions, I'm able to, let me see how this works. Okay, so let's look at this. The mouse diffs is the moves, so think every single time the mouse cursor moves 1 pixel. That's a mouse move. I want to zip that with the mouse move skipping one. Actually, this right here could all have been replaced with that buffer function. Because the reason why they're doing this is to get the offset between one position and the next, and the buffer does exactly that. So when I analyzed this one, I figured out that they could have done that exact same thing using the buffer. Now, if you're wondering what zip does, zip is one that I've used quite often. It's very nice. One of the things I use that for is imagine I give you 2 streams. One of them is a simple interval of 3 seconds, so it just ticks every 3 seconds. Bam. Well, that's fast. Let's say it's an interval of half a second, so it just kicks every half a second. And over here, you have an array of 100 things. And remember, there's no built-in timing to an array. Well, if I zip those 2 streams together, it takes one from here, and it returns them both at the same time, and again, and again, and again. And so now what I have is the numbers 1 through 100 that kick every half a second. So zipping these things together works a lot like a zipper, where the individual tines have to marry up, one and then the other, and then the other, and then the other. So zip you end up using quite a lot. Now look here, the mouse button, this is the interesting part I really wanted to show you. The mouse button is the mouse down, mapping it to true. Merging that with the mouse ups, mapping them to false. Okay, so I have an observable that contains a bunch of trues and a bunch of falses. It contains true whenever I'm holding my mouse button down, and it contains false whenever I've got my mouse button up, or every time my mouse button comes up. And then I'm able to take that and flat map the latest. I don't understand flat map latest well enough to attempt to describe it for you, so I'm not going to. But I flat map that with, okay, let's return a thing that if the mouse button is down, then I want you to give me the difference between the pixels. Remember we calculated the difference in pixels? Otherwise, I want you to return to me an observable that doesn't, it's like a null. It's like a no-op observable dot never. So I actually think that there's a more elegant way to do a good piece of this, but this already shows that this is kind of an alternate way to implement what you may have done with a lot of loops and a little bit of state management in order to capture what happens whenever the mouse moves. And then the subscription is by far the simplest part of this. All it says is that every single time there's a paint event, I just want to go move the, in the context, I want to move to that using a stroke. And so that's what ends up drawing the line using that color. Okay, a couple more examples here. This next one is a really good one because it is similar to the first, something that you do every day, and so you'll understand it pretty quickly. So here I've got a search for Wikipedia. It doesn't actually result in any search results, it just shows you how to do the autocomplete part of it. So let's say I want to look for African elephants. And so I start typing African elephants. Now notice as I'm typing African elephants, it did at one point do something, but it doesn't have to do something with every single keystroke. It can build a delay into there and say, give him a little bit of time, he's still typing. It's been a few milliseconds and he just hasn't typed anything yet. And so notice that there's the searching log down here. And so now I'm going to go ahead and back this all